Mathematics recognizes, classifies, and exploits patterns. By using mathematics to organize and classify our ideas about patterns, we can observe how everything around us is mathematically inclined, just like in nature. Phidias, a sculptor, architect, and artist, studied and created the term phi, which referred to the golden ratio that he often used in his works such as sculptures. The golden ratio can be defined using the Fibonacci sequence, a sequence created by a talented mathematician of the Middle Ages, Leonardo Bonacci. The Fibonacci sequence is the sequence of numbers given by 1, 1, 2, 3, 5, 8, 13, 21, 34, and so on. Each number of the sequence is found by adding the previous two numbers together. The Fibonacci sequence must start with the first two terms being 1 and 1. We see that each number of the sequence is found by adding the two preceding numbers together. Based on the previous example of the Fibonacci sequence, we can see the ratio by dividing the numbers by the number before it. In this example, it would be 1 divided by 1, 2 divided by 1, 3 divided by 2, 5 divided by 3, 8 divided by 5, 13 divided by 8, 21 divided by 13, and 34 divided by 21. Their answers would be 1, 2, 1.5, 1.667, 1.625, 1.615, and 1.618. We can notice that the next divided numbers of bigger values have a constant ratio of 1.618, which is the golden ratio. If we draw a simple rectangle, a line from the midpoint of one side of the square to an opposite corner, and continue on drawing these lines until a golden rectangle is formed. The next is to draw arcs using the golden rectangle as a guide to create what is known as the Fibonacci spiral. As the spiral continues to go through the golden rectangle, its every quarter turn gets bigger by 1.618 ratios. This phenomenon is called the divine proportion, which can be seen everywhere in nature. This is also prominent in architecture. These mathematical concepts are used in architecture to have balance and proportion, making it aesthetically pleasing. One of the Philippine architecture that possesses the quality of a golden ratio is the Cathedral of Our Lady of Atonement located in Baguio. Its main building has two taller towers on its sides. The width of the cathedral from the first tower to the second is a golden ratio to its height at the end of the main building. Another architecture that shows the golden ratio is the administration building of the University of the Philippines, which is where the famous oblation is placed. It can be seen by drawing a rectangle around the structure and placing a line around the third column of the building and continuing to make smaller rectangles with the golden ratio and using it as a guide to creating the golden spiral. The height of the administration building has a golden ratio to its width. We can also see concepts of the Pythagorean theorem in Philippine architecture that involve triangles such as cabins on beaches, specifically in Siargao. There is a place in General Luna, Siargao, called Triangle Palm, which has cottages that look like a hut with its triangle architecture design. Architects use the Pythagorean theorem, which is expressed by the equation a squared plus b squared is equals to c squared, in designing and computing the measurements of building structures. Being able to find the length of a side, given the lengths of other two sides, makes the Pythagorean theorem a useful technique for architecture. Throughout this discussion, we are able to explore the importance of having mathematics in our architecture. By examining Philippine architecture, we could understand these mathematical concepts that were mentioned: the Fibonacci sequence, the golden ratio, and the Pythagorean theorem, which is used to provide balance and proportion to the structures. These are only some of the concepts that are needed in architecture. Not only does math make the structure stable and strong, but we learn through this discussion that mathematics is also beautiful.